Right, let's quickly review all the organic tests which are there in our syllabus, and also what are the important structures which we need to remember. These are the two parts which we will do today. Okay, so let's see. The first part is about tests. Tests of organic compounds. First test is unsaturation. Unsaturation test. If there is any double bond present or a triple bond present, like I have a double bond here or I have a triple bond, then it can be identified using bromine water. So bromine water is always used as a good source for detecting unsaturation. Correct? So this is the reagent that you need to remember, bromine water. Clear? So when it is bromine water, the color changes from reddish orange color. This one is reddish orange color. Reddish orange color to colorless. This is what you will expect to do. Correct? As a bromine water, is there anywhere else it will do any other work? Yes, indeed. If you have an aldehyde and you react with bromine water, here also it will become acid, okay, RCOOH, and becomes colorless. HBr becomes colorless. Got it? These are two places specifically where you need to remember the role of bromine water. Got it? Another place bromine water is used. Another place where bromine water is used is on phenols and anilines. So if you take phenol and treat that with bromine water, it will make a substitution at all three positions, Br, Br and Br here, so which is giving 2,4,6 tribromo phenol, and this is a white PPT. Okay, so bromine water, which is reddish brown, reddish orange color, is changing into white color PPT. Clear? And the same goes to even aniline. All right, same reaction type, except that here we have NH2. So NH2 here. So instead of phenol, this will be aniline. The color is also white here. So this is also one of the cases where you will notice. Here everyone, please remember the role of bromine water in these cases. All of them is changed. In all the cases, it is changing from reddish orange color to colorless or to a white PPT. Okay. Second, another reaction where for unsaturation it will help, right, is Bayer's reagent. So if I take same alkyne or alkene, this in the presence of MnO4 minus, okay, which is generally purple in color, okay, but it must be in a mild alkaline and cold conditions. Mild alkaline and cold conditions. In that case, you will generally notice this as formation of OH and OH like this. Got it? And manganese will settle as, brown color precipitate. Brown, black, TPT. So solution which is purple color is now turning into brown black precipitate and colorless solution. Colorless solution. So this way, it is going to be identified as um, Bayer's test. Alright. So it is also called as Bayer's test for unsaturation. Okay. So I hope this part is clear to everybody. Yeah. Only one part that you need to remember is in case if there is an aldehyde also, and if you react with Bayer's reagent, aldehydes will be oxidized to acid as well. And this will also convert into MnO2. Got it? So here also the Bayer's test will be useful. Right. So let's check out the second one. Second one is identification of aldehydes, which is Tollens reagent. Tollens reagent. Tollens reagent is ammonical AgNO3 solution. Ammonical AgNO3 solution. Got it? So this is used in two places. One is for identification of aldehydes. So where Tollens reagent, which is AgNH3 twice, okay, AgNH3 twice plus OH minus. This is used, which will convert into R COO minus Na plus, or maybe whatever the salt form that is present, plus Ag as the precipitate. Got it? Another place where it is being found is the terminal alkynes. Okay, where the same complex Tollens reagent is being used, and this will give us white PPT. White PPT here, silver mirror, silver mirror formation. So these two are the conformations that we are using Tollens test, Tollens reagent. Suppose if it is in the question it is given, which of the following will give you silver mirror test, then you should only think in terms of aldehyde. Okay. Similarly, when it comes to Fehling's test, got it? This is Tollens test, and same thing we will have similar to this. We will have Tollens test, Fehling's test also. That is R. Let me write down Fehling's test. Fehling's test is when you take copper sulfate plus sodium potassium tartarate. Sodium potassium tartarate in basic medium. Got it? Overall reaction is like this: RCHO plus 2 moles of Cu2 plus 5 moles of OH minus is giving RCOO minus Cu2O, a red color precipitate, plus 3H2O plus 3H2O. Got it? Now here is the interesting part. Okay, so in the first case, if you notice, the balanced equation, the Tollens reagent, is with 3 moles. Is with 3 moles. That is, if you take RCHO, this aldehyde, plus 2 moles of silver ammonium complex. This is very important, that how many moles we are using per molecule. Per molecule, I am using 2 moles in with 3 OH minus. Okay, with 3 OH minus, with 3 OH minus with water, we are getting RCOOH. By chance, if I use water, that is what you have to write. 2 moles of silver, 4 moles of ammonia vapors will come out of it, plus 2H2O. All right, this will be the formation. Not vapors exactly, sorry. 4 moles of ammonia, which will be existing this way. Okay, so do remember that. Next thing is what is in Fehling's test, what exactly sodium potassium tartarate. See, tartarate would be like this, correct? Where you have COO minus, COO minus, Na plus, and K plus. Now, if you have OH and OH, H and H, then this is sodium potassium tartarate. Now, copper 2 plus basically is connected from this end and this end. Like that, it is connected from both the ends of CO minus and CO minus. Okay. Imagine OH, H and H. So from this end and from this end. So one of the examples that was asked, I think 2022, one question was asked, what is the coordination number of copper in this complex? Answer is 4 here. Okay, it is connected from 4 ends. So coordination number is 4 here. So you could see there are 2 moles of it. So here while taking 2 moles of copper 2 plus, remember each copper has 2 moles of this sodium potassium tartarate, which we can write it this way. C4H4O6 twice overall 2 minus and Na plus, or whatever the salt which is present. So this is a representation. Keep this in mind when it comes to Fehling's solution. Clear? Now, typically Fehling's and Benedict are almost same. Okay, only Benedict has citrate, sodium, potassium citrate. That's it. Okay. So, fourth one is Benedict test. Benedict test. Benedict test is copper sulfate plus sodium potassium citrate. Okay. So here the reaction is same, RCHO plus copper with citrate twice, overall 2 minus, and that will convert into, again 5 moles is same, plus 5 moles of OH minus, and that would give us RCOO minus and Cu2O. This is a red color PPT, red precipitate formation here in both the cases. Clear? Okay. Now, citrate would be the structure of citrate would be like this, where we have, COOH. Again, we have COOH here at the end, and at the middle we have one more COOH. Yeah. So 3 moles of this COH with one OH here. And at the center, we have two more carbons, which are at H and H like this. Okay. So total, you can notice that 1, 2, 3, 4, 5. So 5 carbons in this line, 1, 2, 3, 4, 5 carbons. And one more carbon here with COOH group. Clear? I don't have the exact notation of how the structure look like. Here also it is in a complex form where you will have CO minus and CO minus here. Typically this form here and this form here with copper 2 plus will also have some connections like this. Possibly it may not be from COH, but the coordination number is the same. So you will not be asked exactly from where the connection is coming, but you just know that here also the copper has coordination number 4. It is becoming a complex. See, the overall idea is we need to keep the copper 2 plus stable, right? Till the time till the time, what do you say, aldehyde approaches. Once the aldehyde approach to that, now copper will get reduced and aldehyde will get oxidized. Yeah. Next, fifth one is Schiff test. Schiff's test. Schiff test is, if the aldehyde present here with some reagent, we initially made it colorless, and after reacting with Schiff base, if it becomes pink color, if it turns into pink color, then it is, called as the Schiff reagent. Let me show you what is Schiff reagent. Suppose if you have three, phenyl groups here like this. So please make sure that you know that there are three phenyl groups first, like this. And this phenyl group has NH2 on top. This also has NH2 on top here. And this is in the form of an non-benzenoid form here. So plus and Cl minus. Okay. Now this is the Schiff reagent. This is called Schiff reagent. So what we do? We take Schiff reagent, react this with SO2, aqueous SO2. On doing that, this SO2 will get combined here, get added here. Okay. So as it gets added here, so we will have NH2 here, and from here, if you notice, so we can have NH. Here also it will get added as SO3H, and here also we have NH, SO3H. Clear? Sorry, SO2. It's not SO2H. Okay. And here also we will have SO2H. Now this, when you treat with aldehyde, 2 moles of aldehyde here, correct? So this 2 moles would start, making a bond with this OH here, and remove this OH here, and that will retain back the color. Okay. So this would have structure as double bond NH2 plus, and HSO3 minus, double bond like this, with this form here with NH making a bond with S, double bond O, and we will have this as CH here with OH and R. Similarly, here also we will have NH with S, double bond O with CH and R here. Okay. This is a kind of connection it will get. So this is called the colored Schiff reagent. And this color is exclusively observed only when there is an aldehyde getting added here. So whenever there is an aldehyde getting added here, so CHOH here. Whenever there is an aldehyde getting added here, this is what you will notice here. Okay. And this will get further oxidized, again get back into acid form, just like the other cases. This one also going to get converted into an acid case. Okay. Right. Now, out of this test, which are the reagents, which we should be particularly seeing, that which can give or which does not give? See, if I take Tollens reagent, Fehling's reagent, or Benedict's reagent, they both will have similar role, and Schiff's reagent. Okay. First, for general aldehyde, all of them will give positive, any alkyl aldehyde. But if we have benzaldehyde, these two will give positive, this will not give positive. Then if you have Glycerol, if you have glyceraldehyde, okay, sorry, glyoxal here, this is glyoxal, then this will not give, but Schiff test will be observed. Okay. Next, if you have alpha keto, alpha hydroxy keto, then all will give positive test. And if you have an acid, still they will give positive. If you have an ester also, these three will give positive test. Only for this for acids, okay? Formic acid and formic ester. Only for these two that will be positive. All right. And lastly, if you have nitroso group, hydroxylamine, NHOH, then this will also give positive to convert into nitroso group. It will convert into nitroso group. Okay. Well, there are further lot of examples, but we don't have to worry about that right now. So, suppose if you have OMe and OH, this is hemiacetal. All of them will give positive. And if you have acetal, then this will not give positive test. Here, sorry, last one will give positive test because it is in acidic. Yeah, clear. So only these are the forms you need to remember for now. Okay, for advanced, we need to look into lot more cases. But as much as means is concerned, this one, this one, this one, and this one. These four are particularly asked. So please be careful in which case they'll give positive and which case they will not. Okay. I hope all of you understood these three tests. Right. Look out for the next test, sixth one, which is iodoform test. Iodoform test. Iodoform test is all about yellow PPT. First, remember the balance reaction. If you already have a keto form with CH3 group, okay, this methyl group is already present with us, then treating that with 3 moles of I2 plus 3 moles of OH minus, correct? That would give us RC double bond O CI3 plus 3I minus. This is to start with. And the last mole RC double bond OCI3. If you treat with further one more mole of OH minus, we'll convert this into RCOO minus and CHI3, which is yellow color PPT. That's how we get to see what is what is iodoform test. Now, the type of groups which you need to remember, okay, positive test which is given is from ethanol. Ethanol will give positive test, clear? Or any alcohol which has a methyl group on it like this will give positive test. And any aldehyde for that matter, H and CH3, this aldehyde with CH3, any form of ketone like this, any form of ketone here, ketone with double bond here, correct? Or like this also if you have ketone here, okay? On a benzene form also if you have a ketone here, they all will give positive test, got it? Now, especially for JEE mains, they are only emphasizing on aldehydes and ketones. So do remember which type of aldehydes and ketones you need to know. There are a lot more cases which we will do it for advanced, but for mainly aldehydes and ketones, you emphasize that which one should be positive. So double bond O, double bond O. Even this is positive. Clear? If there is a double bond O, double bond OH, this is also positive. Even if it is in a cyclic form, double bond O, double bond O, this is also positive. Lastly, hemiacetal form. So CH3, CH, OH and OMe, this is positive. Now, which one is negative test? Negative test is also important. Which one will give negative test? See, if you have 3-degree alcohol, so it is negative. Clear? If you have double bond O here, but both sides, if you have this way, it is negative. Even if you have this way, it is negative. Clear? Then, if you have double bond O and OAT, this is negative. If you have double bond O, NO2, this is negative. Okay. If you have double bond O and cyanide here, if you have double bond O and double bond OH, acid here, right? So these all will give negative test. Along with that, if you have, instead of hemiacetal, if you have acetal also, it is negative test. OMe and OMe. This is also negative test. So only I'm specifically mentioning cases from mains point of view. So remember which cases are positive, which cases are negative. Clear everybody? So please emphasize on these cases, which will give positive iodoform test, which will give negative iodoform test. Okay. Next, I'm sure all of you have the idea that iodoform is about making this yellow color PPT. Sometimes the question might use the language as haloform test. In that case, you are only checking out whatever the halogen that is forming here. It is not necessarily have to be iodine only. It could be chlorine or bromine, but the reaction is same. Okay, right. Next, next. Where we have discussed Fehling's test, there only let me write down one more test here. So forgot that test. Fine, I'll write down that once again. Okay. Seventh one, check out CAN test. Ceric ammonical nitrate test. You call it as CAN test. Okay. So basically, CAN test is if you have any alcohol, right, 1 degree, 2 degree, right, or 3 degree for that matter, if you treat this with, this is ceric ammonium nitrate, then we will get this as CH3OH, I mean CH3CH2, CH3CH2OH here. This would get connected with cerium and NO3 4 times, complex plus 2 moles of NH4, NO3. Okay. Now this will become first red color PPT, red color complex. And now this is important. If it becomes colorless, sorry, and if it turns colorless after some time, that means it is 1 degree and 2 degree. Okay, if it remains colored, if this remains colored, that means it is 3 degree. Yeah. So ceric ammonium nitrate, here the oxidation state is +4, right? Now, if this gets reduced initially to +3, first it gets reduced to +3 here, and thereafter again it becomes +4 and becomes colorless solution. Then this is particularly for 1 degree and 2 degree. For 3 degree, there is no hydrogen present here. This is that hydrogen which will be removed out to get oxidized. Radical will come out of this. If these hydrogens are not there, it will remain as a colored complex. Okay, so this is the form you need to know. Other thing, cerium here is connected with NO2, NO3 like this, N double bond O, O minus and O minus, and N double bond O, O minus and O minus. Like this, it is coordinating from oxygens like a chelate, okay, bidentate. Okay, it is connecting like a bidentate. So if the question is asked, what is the coordination number of cerium here? Answer is 12 because there are 6 NO3 groups and we have total of 12 uh, connections. So therefore, coordination number of cerium in this case is 12. Now this is particularly important. If the color is not lost, it is 3 degree, which means this test is given positive by 1 degree, 2 degree, 3 degree. All of them will give positive test here. Except that if it is 1 degree, 2 degree, it will become colorless over time and it will remain colored if it is 3 degree. Okay. Next. Eighth one is Lucas test. Lucas test, which is anhydrous ZnCl2 plus concentrated HCl. Got it. So particularly, if you notice, I have R3COH, that is 3 degree. And with this Lucas reagent, it will become R3CCl, which is the white turbidity. White turbidity. This is the form which you will see. If this is 3 degree. If it is 2 degree, R2CHOH with Lucas test, I'll get R2CHCl, which is white turbid, but after 3 to 5 minutes. After 3 to 5 minutes. Clear? And if it is primary, RCH2OH with Lucas reagent, clear? Then no reaction or only takes place at high temperature. Okay, only takes place at high temperature, but you will not see any precipitate forming because in that case you will not see any precipitate form. 3 moles of alcohols were used in can test. One second, let me check. Yeah, sorry, my mistake. It should be 3 moles. In Ceric ammonium nitrate test, there should be 3 moles here and there should be 3 here. 3 moles of that, correct? And eventually these 3 moles will convert into that aldehyde or keto form. Okay. Right. Thank you. Right. This is about Lucas test. Next one is about Lucas test. Now, other reagents, sorry, other alcohols which gives turbid immediately. If this has to give turbid immediately, it has to be stable carbocation. Okay. So if you have a benzyl alcohol like this is benzyl alcohol, it will give turbid immediately. If you have CPM, this will also give turbid immediately. Okay. This will also give turbid immediately. If there is an aromatic form of it, this will also give turbid immediately. Got it? And if you have very stable allyl form, immediately you'll get turbid. Got it? So if you notice these kind where there are stable carbocation forming, then also they will give turbid form here. Clear? So would coordination number of CE changes? Yes, better. Coordination number initially is 12. Here it is 12. Clear? Here it will go, here the connections are still 12 because 4 twos 8 here and 8 plus 3 connections, another 3 connections, 12 connections here. So as much as complex is concerned, it is remaining 12. But from here, it changes to a complex where you will only have water connection like this now. You will have NO3 thrice here like this. Got it? Now, this is where its oxidation state would be plus 3 in this case. Got it? And in this case, it will become 6 now. Okay? Where it get oxidized, reduced. And this part, that alcoholic part will get oxidized to aldehyde. Clear? See, there are 4 of NO3 groups here. So there are 8 connections from here. Clear? 8 connections here and 8 plus 3, 11 connections here. So we'll have with the one with the radical. Achha, connections are 11. Sorry, my mistake. Connections are 11 and it will have one radical on top. Got it? Like this. We will have cerium with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here it is all connected with 4 groups of nitrogen. And here with that alcohol part, here with that alcohol part, and one will be dot present on it. Alright. And that dot is the one which will be absorbed, taking away as a lone pair here and making it to get oxidized. Okay. Right. Next one, Victor-Meyer test. Ninth one is Victor-Meyer test. Victor-Meyer test is specifically used for identification of alcohols. Okay. So what we do, we take primary alcohol RCH2OH. If it is for primary alcohol, okay, all of them the procedure is the same. HI, so I will get this as RCH2I. Got it? And AgNO2. Achha, here you can use HI or red phosphorus. You can also use red phosphorus and I2. Got it? The rule is the same. So first OH will be removed, iodide will come. Next, I'll get this as RCH2NO2. In the place of iodine, you'll get nitro. And then you will use HNO2, nitrous acid. Nitrous acid, what it will do, it will take this H and OH from here. And I will get this as RC NO2 double bond NOH. So an oxime type of a form. Okay. This is called nitrolic acid. This is called nitrolic acid. And this nitrolic acid, if you treat with NaOH, it will become colorless. Red color. So double bond NO minus, Na plus. And due to this conjugation, it will show color. So this will be blood red color. While this is blue color. This one is blue color. Got it? Now everything else is same here in this reaction. So if you take the same reaction here also, except that now this is for secondary alcohol. So I'll have this as R2CH, and here also we'll have R2CH and R2 CH, R2CH. And from R2CH here, when you treat with HNO2, now you will get a very similar type of acid, okay, except that we will have C, R and R, that both the one of the hydrogen which is there, that is gone here. So we will have one NO2, the other one is N double bond O, this one. Got it? Clear? So this is called pseudo nitrolic acid or simply pseudo nitro. This is called pseudo nitrolic acid or pseudo nitro. Now that when you react with NaOH, nothing will happen here. So this will remain blue color and this will be remaining colorless. Sorry, not colorless, I meant to say no reaction. So that blue color remains as the same. So there is no change as such. So it will remain as blue color only. While if you notice it for 3 degree, right, so if the same reaction is done for 3 degree, then what will happen? R3 COH, this will become R3 CI. Here it will become R3 CI, and that will give us R3 CNO2, correct? After that, from here only there is no reaction. So further you will not see any reaction happening. No reaction, and this will remain colorless. This nitrate is colorless. So that is why it is a RBC test, red blood cells. I want you to remember it this way. So this one is red color, correct? So this entire thing, this one is red color. Next we have blue color, and after that we have colorless. So that's how we will have this Victor Meyer test. Important guys, it is there in the lab manual also. So please remember, this could be asked. Next, 10th one. Okay. Next one, neutral FeCl3 test. Neutral FeCl3 test. This is specifically used for phenols. Got it? So if you have phenol, any form of phenol, any substituted form of phenols we have, if you treat this with FeCl3 aqueous, then we will get PHO, correct? We will get this as 6 times Fe as a complex here, T minus plus HCl. Got it? This is how the complex would form. Now this is generally violet. If nothing is given, please go more for violet color. Otherwise, there will be mixture of other violet colors. So remember, close to all the violet colors, whatever they are, that depends upon which all groups you have. If you have any some N groups here, there is some methyl here or ethyl here or NO2 group here. Depending on that, we might get different colors. But now, idea here is this is a test for enol. This is also test for enol content. Okay, test for enol content. If percentage enol is greater than, if percentage enol is greater than 50, then positive FeCl3 test observed. Observed. Clear? So which means other than phenolic forms, where do we see that? Especially here, where you have beta diketone or beta hydroxy diketone like this. So these kind of cases, if you come across exam, you will take them also as positive FeCl3 test. Okay. Again, in mains, they will not go beyond these cases. So do remember phenol or these cases. If you have these cases, these are all positive FeCl3 test. Okay. 11th one, Libermann nitroso test. Libermann nitroso test. Libermann nitroso test is the test for two things. One is for 2-degree amines, 2-degree amines, and for phenols, and for phenols. Clear? So the test is used for both of them, right? Suppose if you talk with phenols, if you talk about phenols with NaNO2 plus dilute H2SO4 or HCl, that will give us nitroso substitution. That is OH and NO. Okay, nitroso substitution. So this is nitrosophenol. Nitrosophenol can be existed as oxime via tautomerism. So this can tautomerize into this form. And this, in the presence of dilute H2SO4 and heat, here will give us, sorry, concentrated. We have to take this as concentrated H2SO4 or dilute H2SO4 and heat. Either ways it works. That will make it double bond O, double bond here, and double bond N, OH2 plus. So this can be relieved, and the next mole of phenol can again get connected onto it, forming double bond N with this phenolic group. Got it? Now this phenolic group is called as indophenol, and indophenol is red color. Right? Indophenol is red color. And once you get this indophenol, react this with KOH. On reaction with this KOH, all we get here is this quinonic form will remain the same. And here, the indophenol form will become O minus and K plus. So because of this new resonance form, it will appear blue color. This is also indophenol, which is blue color. Clear? So it has been observed. First, this will remain as, sorry, here, oxime is green color. Okay. First, oxime will be green color. Oxime will be green color. Then we will come across red color. And lastly, it will convert into blue color. Okay. Now, in JEE mains, once the question was asked, I remember 2 times I have seen this question. This green color is not so much observed, or maybe they have not given much preference to it. As much as phenol is concerned and Libermann nitroso is concerned, their emphasis is more on red and blue color. Okay, so indophenols are what they are more concerned. So if the question is, if the options are given where there is red and blue is used, go for it. Okay, clear? So this blue color is the more significant. Okay. Overall, you remember it as GRB test, green, red, and blue test. All right. Now, when it comes to amines, it is the second degree amine which you will have the importance. So, second degree amines, if you have R, NHR here, when you treat this with HNO2, correct? Now, this will form N and double bond O with R here. Clear? So basically this hydrogen will get N double bond. But this is an yellow oily pigment. Yellow oily pigment. And this coloration is what is Libermann nitroso test. So all you need to check out is a 2-degree amines. If you have 2-degree amines, that means this is also termed as the Libermann nitroso test. Got it? Everybody keep this in mind. Next. 12th one is Phthalein test. Phthalein test. Phthalein test is formation of phenolphthalein. Okay, formation of phenolphthalein. So suppose if you have uh, phthalic anhydride, this is phthalic anhydride, treating with 2 moles of phenol in the presence of H2SO4 here, then you will get same phthalic anhydride like this. Okay, but on this side two sides of it, we will have phenolic groups OH and OH. I told you that this was in one of the lab manuals. I told you to remember the structure, everybody. Please learn this structure, very important structure formation here. So, if you keep it in a basic medium, if you take this into basic medium, that is, phenolphthalein is colorless when it is in this form. If you take it in basic medium, then it will change its structural form here, and this will go away, and you'll get this as O minus, and here we will have this as double bond, double bond, and double bond O, like this. So what is that? This is a non-benzenoid form. From benzenoid form, if you convert it to a non-benzenoid form, definitely there is a change in color. So this will remain pink color. This will be the pink color observed. So both structures are important. Mr. Double bond, No, beta, there is a double bond here. You're not able to see maybe. Yeah, there is a double bond. Okay. So if you have this form, correct, then this is the pink formation which you will observe. Now, important part of phthalene is we will get different colors with different forms of phenols. Okay. So usually if you have naphthol, because this is alpha naphthol or beta naphthol. Okay. If you have an alpha naphthol, correct, typically the color in the phenolic, the color if which you notice here, the color which you notice in the presence of NaOH and I mean sorry, first phenol, first phthalic anhydride, and then followed by NaOH if you notice. Right. So that will be green color. This will be green color. If it is beta naphthol, if it is beta naphthol, you will have faint green color. If it is resorcinol, yellow green. Cresol, cresol if you have red color, correct? Only one thing you need to notice that there should not be any group and para. Okay, so that means which will not give. Suppose if you have phenol here, there is a nitro group here. Okay, I have phenol here. There is a CH3 group here. This is paracresol, paracresol, or phenol here. There is a chlorine group here. Okay, or phenol here, clear? Uh, Phenol here, and we have maybe OCH3 group here, like this, correct? If you have these kind of groups present, if you have these kind of groups present, then no Phthalene test observed, because the connect majorly always happens from para position. Okay. Okay, Virat, I got it. You're referring to this one, right? So remember, in this case, no Phthalate test. Now, this one has been, paracresol has been asked many, many times. You must have seen in a lot of PYQs there, where they have been mentioned, which of the following does not give Phthalate test. Got it? So note that this is what you are referring to. Okay. Next, 13th one, 2,4-DNP test. 2,4-DNP test. This is a test for aldehydes. This is a test for aldehydes or ketones. Take this one or this one. Aldehydes or ketones. When you treat with, you know, uh, hydrazine. But which hydrazine? Phenyl hydrazine. But what type of phenyl? 2,4. 2,4 dinitrophenyl. One second. Hello. Right. So with this, if you make a test, so this part will remain the same, and here this N will get connected to carbon with R and R. Okay. This usually gives yellow orange crystals, yellow orange crystal form. There are other colors also you can get depending upon what type of aldehyde and ketone you are taking, but this is mainly test for aldehydes and ketones. Test for aldehydes and ketones. Clear? This is a test for aldehydes and ketones. Next, 14. Sodium bicarbonate test. Sodium bicarbonate test. Sodium bicarbonate test is simply based on pK values. If pK value is less than, 6, if less than 6, then okay, chances are chances are they give positive bicarbonate test. Positive bicarbonate test. Okay. Which of those groups? So if you notice, mainly remember these cases. Phenol with two NO2 groups, not one, but we need to have two NO2 group. They could be positions anywhere. Two ortho, two para, one, two meta, one para, one ortho. Any kind of positions. Next, if we have three NO2 groups positioned anywhere, correct? They will give positive. Any form of carboxylic acid, okay, that includes formic acid, right? That includes acetic acid, CH3COOH, oxalic acid, everything, okay, diacids and all of that. Clear? Then ascorbic acid. I told you to remember the structure also. Like this, we'll have OH, double bond OH here, double bond O, and here OH and OH. Clear? Ascorbic acid. Then squaric acid, like this, OH and OH. Sorry, double bond O, double bond OH and OH. Any form of sulfonic acid, RSO3H. Next, picric acid, OH, NO2, NO2 and NO2. These type of acids, if you notice, definitely they all going to give you positive bicarbonate test. Alright. Please remember in which case what type of test is being used here. Okay. Next. 15th one is about carbylamine test. Carbylamine test. Carbylamine test overall reaction is when you have RNH2. That means you need to have 1 degree amine for sure. And this R could be alkyl or aryl. Does not make any difference. That if you react with, KOH, so 3 moles of OH minus plus CHCl3, right? Then you will get this as RNC, and here RNC plus H2O plus NaCl or Cl minus. I'll just simply write it as 3 moles of Cl minus. Got it? So this is isocyanate, which is foul smelling gas. Isocyanate, which is foul smelling vapors and gas. Right. So remember what is carbylamine test? Mechanism and all is not required at this point of time. Google says paranitrophenol was positive NHCO3. This was given as a bonus. Once J means it was given beta Ravas. So this was claimed and that was given correct. I mean, it was given that paranitro will not give positive bicarbonate test. Okay. So don't worry, we have enough data to support that. Okay. Next. 16th one, Hinsberg test. Hinsberg test. Hinsberg test is a test for detecting 1 degree, 2 degree, and 3 degree amines. Okay. If it is 1 degree amine, okay, the route is like this. RNH2 here reacting with benzene. Let me simply write down this one. pH SO2Cl. And then you will get a white PPT of NH SO2 pH. Here, this is that white PPT form. And in the presence of NaOH, this will become soluble, soluble, colorless solution. So this will become a soluble solution here. So if it is 2 degree amine, if it is 2 degree amine, R2NH with pH SO2Cl, you'll get this as R2N SO2 pH. Again, white PPT form here also. But since there is no hydrogen anymore, you will not see it is being soluble. That means it will remain insoluble. 3 degree amine R3NH with pH SO2Cl remain as R3N SO2CH, but the equilibrium mainly lies in the backward direction. So it will hardly make any reaction. So this will remain soluble, soluble form only. Okay. So the question could be asked very smartly. If the question is asked, there is no reaction, please go for it. Okay. If the option, best option is out of the given options, if the option is no reaction, you can go for it for 3 degrees. Okay. Because it is almost equivalent to say there is hardly any reaction happening here. Or if no reaction is not the case, if no reaction is not the option given, then you look out for the option where it is said remains colorless. Okay. Remains soluble. Clear. So if this kind of form is being given, that means it is for 3 degree amines. Clear? So I guess this part is clear, everybody. Right. Next. Done? Right. Now, let us see biomolecule tests. First one is Biuret test. Biuret test. First one is Biuret test. Right. Biuret test is mainly for, polypeptides. Polypeptides or dipeptides, at least dipeptides. You cannot have monopeptides as such. Right? So which means if you have this connection N2C double bond O NH C double bond O NH2. You can see there is at least two connections here. This is one C double bond of NH and this is another one C double bond of NH, like this or this way also. correct? If you have two connections, then it is called, we can say it is giving positive Biuret test. Now, this is what we call it as Biuret. This is Biuret. This structure's name, in fact, this is a structure's name which is Biuret. Now, if this is a case, if you have multiple nitrogens like this, see one, two, three, these kind of nitrogens which are there, that will give a violet coloration with copper sulfate. Okay. So if you have this Biuret form, so we can have this as R, CH, C double bond O, NH. This NH connections are N times here, plus copper 2 plus. Copper 2 plus, which was originally blue color solution, is now converted into a complex, got it, where it gets connected from all the directions here, where you have nitrogen, 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 and nitrogen. Okay. So at least if there should be one mole here and one mole here, which are connected with each other. Like this here, you can see this one mole and one mole. These two can connect from here, or these two can connect from the other end to the copper, like this. Okay. Here there could be some structure here. Here there could be some structure here or connections between these two. Okay. And a part of it, we can have H2O and OH2 present this way. Okay. So if you notice that the coordination number varies between 4 to 6, so far in JEE it was never clearly asked what is the coordination number, but I suggest go for 6 because most of the books has given a similar structure like this. Okay, go for 6. And what is the type of groups that we need to observe? Right? Is it only for amides? Not necessarily. If we have C double bond or NH continuation, C double bond or NH2 at the end also, or CH2 NH2 also. Okay, but there should be two or more than two groups. Then we have C double bond NH and NH2 also, or C double bond S and NH2 also. These kind of groups, we should have at least two of them, then that is going to give you Biuret test. In short, this test is mainly for polypeptides and at least for dipeptides, not for simple amino acids. Okay, this is Biuret test. 18th one, which is most important in this section, is Ninhydrin test. Ninhydrin test. Okay, for Ninhydrin, basically you are using any amino acid or protein which has at least NH2 group. That's it. That means it could be basic amino acid or a protein or a polypeptide, anything. So this is test for amino acids or proteins with free NH2 here. So as long as we have this free NH2, this test will be positive. Got it? So in case if you have any amino acids like this, which you have NH2, then we have CH, some R group here and COH. This is basic amino acid. I take 2 moles of ninhydrin. This is ninhydrin. The structure which I'm writing is ninhydrin. Double bond O, like this with a double bond O. Here, this is ninhydrin. Acha, ninhydrins are very famous for their hydrates because if you take this ninhydrin and hydrolyze it, correct, it will form a stable hydrate formation. Got it? Due to its very strong hydrogen bonding in here, you will see this is how we'll have OH and OH form, and that will give very stable hydrogen bonding because of its this is the hydrate of ninhydrin. So this is a very stable form of ninhydrin. So do remember that. So now this ninhydrin form, when you react with this 2 moles of this, when you react with it, again mechanism is not very clear to me as well in terms of how exactly the first step or rate determining steps are. But this is the overall reaction that has been noticed. Got it? So the reaction that has been noticed is These two would get connected with one nitrogen double bond of the second molecule here, like this, with double bond O and double bond O. And this is usually purple blue color. Okay. Okay. Here I didn't write the color, violet color. It is violet color. Here, here it is purple blue color. Done. So this is the purple blue color which is formed, and the aldehyde part will come out of it, RCHO. Okay. I hope all of you got this. Ninhydrin test. It is for test for any amino acid or which has free NH2. Achha, which amino acid will not be able to give this proline because that is the 2-degree amine. So that will not give positive. 19th one is Xanthoproteic test. So notice what is Xanthoproteic test. Xanthoproteic test is reaction with HNO3, correct, to make an EAS reaction. That is electrophilic aromatic substitution. Okay, EAS of EAS of uh, aromatic, okay, aromatic amino acids, aromatic amino acids. So if you notice this one here, here we have COOH and NH2, correct? With OH group. If there is a phenol present on this, this is called tyrosine. This is tyrosine, correct? And then we have benzene connected to NH here, like this, with COOH and NH2. Clear? This is tryptophan. Tryptophan. And lastly, we have only phenylalanine, COOH and NH2. This is phenylalanine. Phenylalanine. Mainly these are the three compounds which you will notice, isn't it? But out of this, see, if I made nitration here, that is HNO3 reaction here and HNO3 reaction here and HNO3 reaction here, correct? So if you notice these two structures, they can easily take up NO2 at any of the position because ring is sufficiently activated. So one NO2 group will come here, and one NO2 group will come here. But here, unfortunately, the ring is not sufficiently activated to make this reaction. Okay. So with phenylalanine, you will see a very mild reaction, correct? But with these two, you will get a strong reaction. And most of the time, they will avoid giving phenylalanine as the option. But listen, be very careful. Suppose if phenylalanine is given and there are three other options which has no benzene ring on it, then only go for phenylalanine. But if these are the cases given, tyrosine is given, tryptophan is given, please give preference to these two. Got it? I hope all of you understood that. Xanthoproteic test. Clear? So what is the color here? So this will convert first into an orange color. Okay. The aromatic rings, I mean yellow color. These are yellow color solutions. Yellow color solutions. And if you add alkali to this nitro salt, that will convert into orange color. So adding this to NaOH will give you orange color. So this testing is what we call it as xanthoproteic test. Okay. Fifth one is Millon's test. 20th. In this case, it is 20th. Millon's test. Millon's test is the one which is again specifically used for tyrosine. It's mainly for tyrosine. So the reaction is like this. Sorry, we already made a structure. Let me just copy. So if you have tyrosine and treat this with HNO2, if you treat this with HNO2, right, it will become a nitroso group. So basically here this entire thing we have an R, here we have OH, and this will convert into N double bond O. And this N double bond O will exist like an oxime, and in the presence of H2, Hg2 plus, it will form a complex Hg with four connections here with oxygen, another oxygen here, oxygen and another oxygen. This is connected to that double bond NO, and this is the one which is connected to that phenolic form like this. This is that phenolic form which you have. All right. This is the R connection. Same logic here also. Correct. So this is reddish brown complex. Reddish brown complex. Okay. 21 is Sanger's reagent. Sanger's reagent is also to identify free NH2 group, free NH2 group in amino acids, or peptides. Got it? That is, if you have NO2 here and NO2 here with fluorine on top. Now, if you have NH2 here and we have some R group and this thing is continued here, this is all, I mean, this will have something like double bond ONH, and like this it is continued. This kind of chain is there. Then it will take away this NH2 as a substituent by ARSN reaction. By ARSN reaction here. So NO2 here with, instead of fluorine, now we'll have NH connection here with R double bond NH and so on here like this. And this on hydrolysis will convert that into NO2, NO2, and here we'll have NH and R and COOH plus other compounds. This is how you will notice the compound formation. Okay. So mainly this test is to identify how which is on the terminal side, which amino acid is on the terminal side. Okay. Detecting N and amino acid, detecting N and amino acid. So this is dinitro fluorobenzene, DNFB. If you notice this one, this is what it is, dinitro-fluorobenzene. Got it? Next, 22. Now you will see this is a test for carbohydrates. Okay. So first one is Molisch test. Molisch test. Molisch test is mainly for any oligosaccharide, okay, plus H2SO4, and then on hydrolysis you'll get this as monosaccharide, and this monosaccharide here, this monosaccharide will be converting into a compound called furfural. For example, if you take benzene, if you take the benzene form here, we'll have OH like this, we'll have some OH here, OH here, correct? And OH here like this. Okay. This is the, sorry, I mean glucose form. This is the D-glucose form. So suppose if you have a D-glucose form and dehydration, this on dehydration, it can convert into a form like this. By removal of water, it will convert into this aldehydic form with OH. And this is called as furfural. And what is that furfural? 5-hydroxy hydroxymethyl 5-hydroxymethyl furfural. Okay. The objective is to first make furfural, which means what you need to do. You take any oligosaccharide or for that matter any monosaccharide or any oligosaccharides on hydrolysis, strong hydrolysis. First they'll convert into monosaccharide. Then you dehydrate them. On dehydration they'll convert into furfurals. So once you get furfural, and this furfural is supposed to be reacted. So we have CHO and OH. This is that furfural which we got with alpha naphthol. So you get this as OH and this is alpha naphthol. So on reacting with alpha naphthol, you would see 2 moles of this alpha naphthol will get connected from the para position. So from this para position, we will get a connection here like this with furfural. This kind of a connection is established. So basically this aldehyde which you have will undergo EAS. 2 times EAS will happen in the presence of H plus. So we will get this compound. Now this compound, if you know, if it is being oxidized here in the presence of acid, it will convert into a purple color or violet color. So the same structure which we have here. If we write it in the double bond here with double bond O like this. Done. Now this is a purple coloration. Purple color dye. So Molisch test is mainly to recognize any monosaccharides or oligosaccharides by formation of furfural reacting with alpha naphthol and oxidation. Next one is Barfoed test. Barfoed test. Okay. Here, this is to differentiate from monosaccharide, monosaccharide and disaccharide. Di and polysaccharide, all of them. Correct. So what it happens is first if you have an aldehyde plus 2 moles of copper 2 plus 2 H2O, you are expected this to form RCOOH, it will get oxidized and you will get red color PPT. So this is same as Fehling's test, except Fehling's test is that basic medium. Here it is in this aqueous solution. Got it? So if you get this form, then it is Barfoed test. Mainly, like I said, Barfoed test is used for differentiating monosaccharides and disaccharides. Clear? Next, 24. Seliwanoff test. Seliwanoff test. This is the test for identifying fructoses. Okay, only for ketose sugars like fructose. Got it? You're checking out for fructose. So if you take the fructose structure, like for example, if you take this particular structure here, like this, OH will be up here, OH and OH here, and this one. This is fructose structure. Fructose structure, if you heat it in the presence of dehydrating agent with H plus, then this will also get dehydrated, converts into a furfural form, like this CHO and this one. So what are we getting again? Furfural. So this furfural form, correct? If you treat it with O2 in the presence of resorcinol, so we need to take resorcinol. This is resorcinol. In the presence of resorcinol, it will give a cherry red precipitate, like this. From this oxygen's end here, this is how it is connected, and this is where it will connect it to that furfural, correct? And here is that OH group. Sorry, this one is in the form like this, and OH group here. Okay, so this is that cherry red precipitate. See, for these reactions, whatever I am writing, correct? Only one time there was a question asked based on Ninhydrin structure, last structure. I mean, just last year only it was asked this structure. That's it. Mostly these reactions, right? Xanthoproteic test or Millon's test or Molisch test, Seliwanoff test, they are not particularly asked with the reagents, what exactly it is, what is the structure. You just need to identify which type of carbohydrates you are dealing with. That's it. As long as you are aware of that, that is good enough. Okay. I guess this is done, everybody. Okay, right. See, as much as the test is concerned, only these are the tests which you have it from, mains point of view. So please learn this test, everybody. Lastly, I just want to emphasize on DNA structures. You have to learn it. Otherwise, I'll make you remember it one more time. Sir, is it important to remember the reagents, or is enough we learn which gives positive test? Reagent also, beta, not the reaction. Just what is the reagent used, correct? Along with the reagent, whether it is giving positive test for which type of forms, which type of carbohydrates it is giving positive test. That's it. Okay. Next, vitamins. Vitamins is one thing which you shouldn't avoid here. So notice all the cases. Table is given. Just refer to the NCERT. Vitamin A, vitamin B. Within B, we have B1, vitamin B3, vitamin B3, vitamin B12, okay, vitamin B5, and vitamin D, clear? Vitamin E and vitamin K, clear? So mainly check out their deficiencies. What are the diseases which are caused if you have deficiency? And lastly, if you notice vitamin DEAK, DEAK are fat soluble, while vitamin B and C generally are water soluble. You got it? Okay. That's it, guys. Don't take too much load on this. Just go through it once. If you get time, my suggestion is again go through all these 24 tests once again. What are all the tests which you need to remember in terms of the reagent, in terms of the reaction, colors? Please go through it once. And lastly, check out two important things: DNA structures and vitamin uses. Okay, I mean deficiencies. Correct. So let us focus on this part for today. Tomorrow I'll discuss everything regarding inorganic reactions, okay, which are important and specifically from trends point of view, what all things we need to know. Correct.